Hold on. Missing error, I guess. Loads of missing errors. Line style. Yeah, node is defined. Draw line. Going to need a connector style as well. Probably draw connector. Let's find it anyway. Totally. This is a problem. Also, I moved this into namespace creating descent. This is kind of silly, right? Can't just delete that. All those plot things. I guess I'll just make separate headers for those as well then. Plot history, plot parabolic scale, plot kinetic energy. That's 3 of them. Let's start with that. No, there's only 4 of them. And then I have to add all the headers for this header. That is really silly waste of time, right? Something like that should not be necessary. Oh, wait a minute. This is not in namespace gradient descent. Jesus. Yep. Layer. Still this one, I guess. Yeah, but plot already includes a layer, of course. You see, that's including like everything. I don't know, I don't see a layer. Maybe it is easier to just start compiling and then add headers on you, run into something that's still missing. So this was parabolic scale. Okay, next. The plot history was it? Once. Again, everything else. What was the other one? Layer. Yeah, whatever. properties do. While I'm at it, I might as well move the... I thought there was only one left. Now I see two. Oh, this is struct. Yeah, I was looking for class plot. Struct plot, just one. So I can move this one and then the other class plot also to their own header. I mean, why not? Funny how you can start with a little test program and then it grows and grows, and now I have like 50 hairs. Okay, not 50, 20. If that, but still. Maybe you have to include point. I don't know. It's probably Cairo in the point. And then the class one. Yeah, well, that's the first create file. This thing has a print on. Let's add the debug for the headers for that as well. Otherwise I'm going crazy. Doing that later. That means I need to find something with has print on, which tells me what to do. I have to include that in the namespace. There's no namespace here. Duh. Sure. And we need this header. And then I need to add that to all my new headers that have a print on. This is no print on. Also no print on. It's like the first one. Only on. This one does. Yeah. Well, in that case, so now in this file, and I do no longer have class plots, and also not struct. But, yeah, I moved that. I need to move these things as well, though. So they need to go to a .cxx file. Ugh. For now, I can put them here, I suppose. The moment. Beats me. History was one. Can't type. Local extreme. I don't know anymore. Parabola scale. Kinetic energy. Let the errors begin. They all need to start with Cairo window. I'm doing grep. No, I solved all mass stack exchange problems. Plot history is missing. It's included. Well, actually. Plot parabola scale. Parabola scale, is that not including scale? Of course it is including scale. It is gradient descent, sorry. I don't have that yet. It is including scale, so I might as well not include that here. Plot sample. What was that? Right. Mm-hmm. It's my favorite pass of time, adding missing headers. No print using a namespace utils. Oh, I bet I'm not even using it anymore in the previous file. That's another thing. You can add headers as a result of compile errors, but that means that I do not delete headers. So what I'm doing is I had a file it's a test file.cxx CPP for the newbies. No, I'm just kidding. And yeah, splitting it up in a lot of files. So I'm splitting this one. So the question is, do we still need this here then? If I just add it to the other file. Probably not, because it's not mentioned. And apparently I should here, oops, do if it's not include headers we don't need. Yeah, way too soon. Well, I don't have the feeling at all that I did my headers correctly, but well. So that made gradient descent a lot more. Haha. Now I have functions defined, for example, this function. And it should not be highlighted because it's commented out, but editor is getting confused. And then we just have main. So the function is defined called L. which the function that I choose with the if else stuff also gives me the starting point and an indication for the minimum and maximum values. And then this is just debug code basically, because it's plot stuff. Plotting is not part of the algorithm, just for us to see what happens. This is the real loop. Start with some initial value for W. W is W0, it's the starting value. Plot, 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 plot. And now we call gradient descent algorithm on it, which zooms in to the global minimum, and then when it's done, W has become the global minimum. To break, print it out. So it's really a tiny loop around this call here. That's the idea. Then the GDA, aka the gradient descent algorithm, is hiding the whole algorithms thing, which make this file no longer interesting. It should still do the same thing as before. That is not work. So this is my horrible curve, crafted to make my current algorithm fail, and yes, it does fail. So it found this maximum, and now it wants to find this minimum here, but it fails. No, got stuck. No extreme is found at all. No minimum, that should say actually. See best minimum, X extreme. Yep, so I did this split off because I wanted to rewrite the whole thing. Did I really want to do that? Do I really want to do that? I think I do, because it will give me a better overview, probably better code. Okay, the idea is if I have only one sample, well, then it's clear what you have to do, I think. let's see. The problem with this algorithm is that I don't even have it in my head. It's very hard to code when you don't have it in your head. It would be nice if I just had a drawing program where I could draw stuff with my mouse, but I can show it, I guess, by running this and then pointing at it. The idea is that, well, in this case we have only one sample, yeah? So this is the only sample here. So I have the height and the slope. And I think that the best thing that I can do at this point is decide where to go to. And before I was just making a little step and then I had 2 points. And then I go from there. And then having 2 points decides that it looks like a parabola. And therefore, why not let's go to the vertex of that parabola, which is a maximum. But maybe I have been thinking since this morning. I just should immediately start looking for a minimum in this direction, because the slope is down in that direction. This is the global minimum, by the way, but on the other side it's going a little bit like a sinus, so up and down, but never as deep as this one. Nevertheless, why not go that way? What would happen is then we find the minimum here, and then we find the maximum there, and then we find a minimum here, and that minimum is not as deep as this one. Therefore, we stop searching this direction. Then I go to this best minimum that we found, and then we go explore the other way. So then we go to this maximum, and then find this minimum, which isn't worse at all as immediately going to the maximum. Well, hardly worse. Immediately going to this maximum, then finding this minimum, then finding that there is no maximum on this side, then jumping back to the best minimum that we found so far, and then going back to this maximum again in order to be sure that we have all minimums left and right of the best minimum. Well, best minimum. So what this algorithm does, it finds a local minimum, and then it explores the local minima on the left and the right. And if they are both not as deep as the one that we found, then we stop. So if you first go to this maximum, actually it doesn't decide on a direction yet. It just goes to the maximum and then fits a 4-degree polynomial here, and then decides to go this way because it's 4-degree polynomial. I can show that, I guess. So now we found the maximum here, and this is the 4-degree polynomial. So that goes, it probably follows, yeah, you can't see it. It's maybe I should increase the size a little bit. Let's go to 40 here on the scale, so you can see what happens on the other side. Descent. That would be my W0. No, not W0. The maximum. So I make that 40. So now you can see the other one as well. So on this side, this straight line here is actually a parabola with a maximum on the left. So it looks like something that's curved like this. Yeah? But if you go further to the left, which again I don't show, it changes into a parabola that goes up. So basically it's a parabola that goes up, and then it looks like a parabola that is curved like this, very shortly, almost not. And then we quickly change in a matter of very short time, we change exponentially using the sigma function from that parabola to the sine, which is this sign here, which has an exponentially decreasing amplitude. So it's going like one bop, bop, bop. So there is no minimum or maximum on the left. There's nothing there. So if we would decide first going to the maximum, which I'm doing now. Yep, find the maximum. Then we plot a fourth degree polynomial. And then it decides on the direction based on the height of the minimum here. So this one is here, and the other one is clearly lower. You can't even see it. So that's why it goes to the left here, because this thing is just way steeper. Which is a good prediction, because the global minimum is indeed on this side. But yeah, I mean, if this side then gives me a series of minima that go deeper and deeper and deeper, then I will never investigate this again. So that maybe it is the best thing to do actually then for that reason. Okay, I won't change it. I won't change it. So the goal is then to find the nearest extreme, which in this case is a maximum. Then we fit a fourth degree polynomial. We can also do that in a minimum. And then we decide on the direction. From that moment on, we really only explore in that direction until we find a minimum that is not as low as the last one. It's not that simple actually, because it could be that this fit is so wrong that the jump to the minimum, so you can see that one here, let's say this minimum is like way to the left, so we completely overshoot this minimum and we go way further to the left. Someone is making noise in Discord. How the hell did that happen? I'll just leave this chat there. So leave the voice chat there. So yeah, it's possible that we completely overshoot the minimum that we are looking for. That is the minimum, the next minimum immediately on the left. But then find another minimum that is even lower. Then I'm like, yeah, okay, forget about the minimum that we just skipped. This one is lower anyway, so just go there. But that means that we might have skipped the actual global minimum as well. It could be that you skip over a lot of minima, including the lowest minimum, the global minimum, and still do it because the minimum that you find on the left is lower than the one that you had. So it's not necessarily the case that we indeed find them exactly in sequence. Therefore, it is possible that the direction, the horizontal direction is inverted, I think. I got so confused about this. This is why I wrote the histogram test, which deals exclusively with extremes. Could show that, but I don't think I will. Yeah, I see you with CDKW2. I see you joined Discord, yeah. Yeah, you asked, can we now just stop when we find the lowest? Well, I want to find the lowest, but you don't know if there is anything lower on the left, so we have to go to the left. Well, I'm not going further than that it reaches this height, where it says energy, that horizontal line here. So we explore it in this direction until it gets higher than this one, and then I give up. I'm just a little bit confused about what to do in this startup, but okay, the startup works. The thing that goes wrong is more later on. Like in this case, we do decide to go to the left of this maximum here. And we jump there. Apparently the minimum of this 4th degree polynomial was here. And now it goes wrong, because now it's going to fit, it goes in the same direction, and now it fits a parabola through this. Like I said, this straight line is actually parabola like that. So now it thinks that it has a maximum on the left. Now you can actually see it, I think. This is the red line is a straight line. So you see, if I don't know if you can see that on YouTube. But this, the blue line, it goes a little bit below it here. Just in a little bit, but still. No, what I really want or should have done, I'm going to do, is sort of a binary search. So think of from 3 we jump to, no, from 5 we jump to 6. And that should already tell me that I jumped over the minimum. So then you have a point. I mean, you can just look at the derivative here and the derivative here, and then the derivative changes. So yeah, there must be a minimum in between that. So we kind of can do a binary search. I have the, let's say, the 3 here and the 6 here. And the minimum must be in between. And you can find it by plotting a 3rd degree polynomial that goes through exactly through those points and has exactly the slope of those points. I don't know how it will look, but that will have a minimum in between. And then we jump to that minimum. And then you have to find out, you know, if it is left or right of that minimum again by maybe plotting 2 3rd degree polynomials, the new point and 3 and the new point and 6. And that way we can quickly zoom in on this minimum. And then once I found it, I can use the algorithm that I found while designing the histogram.cxx test. I just think that the current code is very distracting. So I really want to start over completely. But the start up is a problem. I could say, well, fuck it. I'm just going to write 2 pieces of code. First, the code to have the initial start up. So like in this case, we find this maximum here, fit the 4th degree polynomial, and decide on the direction. Then we can really start. But if I would make a jump, and like I said, that jump ends up way lower than the minimum that we found so far, then I would go there anyway, and we kind of reset at that point. So then I again have just one sample. I mean, I ignore all the other samples. So we have just one sample again and one line, and it's kind of the same as the startup then. I guess that the difference is knowing in which direction you want to go or not. Yeah, it's definitely that is definitely the difference, I think. So there are two different modes. A mode where we have not decided yet if we want to go left or right, and a mode where the decision has been taken. But it's at least as important to know if you are looking for a minimum or a maximum. For example, this is a maximum, we want to go left, therefore we are looking for a minimum. And then if you get into at 6, we know we have to go backwards because we want to look for a minimum, and we overshoot it. But once you found this minimum, then we want to look for a maximum. If then we end up in 6 again, then we don't want to go back. To the same point, same slope, but in this, if you want to find this minimum, we are in the mode that trying to find the minimum between this point and that point. But a bit later, we're going to have 6 and 7 or whatever, 2 points here. And we want to find a maximum. Is it that we want to find a maximum and therefore we go left because the slope is upwards? Or do I already know that I want to go left? Something that has equally confused me while writing this. The algorithm currently already has a notion of horizontal direction as well as a vertical direction. And it's not clear how those interact, really. I tried to get rid of vertical direction at some point. Just started deleting it, and then things went horribly wrong. I had to add it back. So the notion is needed. You must know if you're looking for a maximum or a minimum. But then you ask yourself, would it be possible to be in 6, wanting to go left, that's the horizontal direction, and wanting to go down, looking for a minimum? I would say, okay, then something went wrong. Because that should only happen if I want to find those extremes in sequence. So if I want to go, let's say that this thing goes up, but let's say it goes down again, okay? Let's say this is a sinus as well, like this. Then I want to find this minimum, which then would be the minimum that I'm apparently looking for, because I want to go left and I'm looking for a minimum, so we're looking for this minimum here. But since I want to find them in sequence, I want to find that one, and then that one, and then that one, and then that maximum here, and then that minimum here. So if I'm here and I'm looking for that minimum, that means that maximum must already have been found. And it beats me completely how I ever would end up on this side after already finding this maximum here. But, okay, I mean, theoretically, it should be able to recover from situations like that, I suppose. Yeah, the current algorithm has, of course, has been developed for a month already, so months. So it's not completely stupid. What it currently does is it says, okay, I'm fitting a parabola through these 2 points. That gives me a parabola with a maximum. and therefore I have no idea what the minimum is, where the minimum is. My current approximation does not have a minimum. But I know I want to go left. So what would happen is it just goes left without even taking the maximum into account. Which just makes a step that way. And then at some point we just pass the maximum and then we do find the minimum. See, there's a big difference between having 2 points with the same slope and a height such that it's very unlikely or possible that there is an extreme in between them, or the extreme that you're looking for in between them, and the situation where that is the case. So, I mean, I must know if I'm looking for an extreme that is left or in the middle or right of the 2 points that I have. That decision has slowly been made that over the month, basically. I'm only going to work with 2 points at most. So the could be 6 and 7, and then say if 6 and 7 are here and we want to find a minimum on the right, aka that one, then I would be fitting a third degree polynomial through them. But let's say, I don't know how that looks like. Let's say parabola. I know the parabola looks like this. So that has a maximum on the left. But I know I want to go to the right. So I would ignore that and just go to the right. I think even does that now. See, it just goes to the right. It ignores it. I think even the next one, right? The next one also. And now it gives up. I don't even know why it gives up, actually. So let's say in the beginning or after a huge jump, we have just one sample and we do not know if we want to go up or down. I think in the beginning I just decided that it would be best to go to the nearest extreme, or I'll just make a little step, do an approximation. And then if the approximated parabola has a maximum, then we just go there, if it is near or something. But after a big jump, we make that jump because that point is lower than the minimum that I found before. I think then I should start looking for a minimum, period. Okay, so we are somewhere new and we know that we want to look for a maximum or a minimum, or we don't. No, we don't know if we want to look for a maximum or a minimum, or we know that we want to look for a minimum. That's all. 2 different modes then. I'll write that down. Damn it, I don't want to use based. No. Well, lost connection for a bit there. It's not entirely true. difficult to describe, man. 3 places. One in do step, and these in handle local extreme. How do you describe this? That would be this one. So this in this simplification here, this means that it is immediately next to it. I mean, every extreme is at a distance of 1 of each other. So if the last step was 1, then we clearly now have reached an local extreme that is immediately next to the previous one. And then that previous one is marked as being explored in the current direction. And then the current extreme is marked as explored in the opposite direction if we already saw a minimum. Since the last jump, I guess. That would be that one. And then I have one more here in do step, but this is when step is 0. So when jump returns 0, which means that it wasn't possible in that direction. So that means that the current, I think W is the current one here. Yeah. And the current one does not have an extreme in that direction. Yeah. It is explored to the left, right? So why would it not be explored to a given direction? In. Uh-huh. I'm using in here. What was I thinking? Yeah, I've been doing it correctly, completely. Okay then, whatever. Yeah, in this case I'm not sure. The when is probably not the best thing here. Let's use if. So multiple choice. In this case, oh no, I don't know. Somewhere I used when. The algorithm terminates when, and then it's just a single case. I think I'm convinced that it terminates, so that would be good. But here I say to know when to terminate. Okay, that's something else. The algorithm terminates when. After jumping back to the best minimum, that minimum is already marked as being okay. It's also a single thing. It's kind of the same when as there. Uh-oh. Yeah, no. So I have to weave in the sense of direction here. Super vague. Mm. Yeah. If an axiom that is found is immediately next to the previous one or not depends on whether or not a reset found place in between. Okay. Yeah. Yeah. What to say here? Did I miss something? Looking for any extreme only can happen when we did not find any previous extreme, because otherwise we look left or right from some extreme. And then we know what it is. So this must always be the initial one, and then after that, well, we have more than one sample, but still initial. And after a reset, we can have another case of one sample. But in that case, I always want to look for a minimum. And then, of course, take one more sample, and we are doing this without knowing if we want to go left or right still. Or do we? Actually, after one sample, I already know which one, which direction to go, of course. You can just look at the slope. So this is kind of nonsense then. You just take another sample and then you have two samples, but we already know the direction. We still have to decide though which of these it is. Let's put the minimum closer. Say left first. So the minimum left. And then the minimum between. And then the minimum right. And do the same order here. For the maximum. This is also kind of dubious because as soon as I have two samples, I probably know if I'm looking for a minimum or a maximum. But yeah, I mean, we begin with not knowing it and then we figure it out, so it's a bit unclear, I guess. It's not known at the moment we enter. What the hell do I have here? Yeah, I think I'm going to stop. Continue.